Good morning, everyone. So today's topic we are going to discuss is about EBGP adjacency, with the help of loopbacks. So we have R1 and we have R2. So R1 is in autonomous system number 1 and R2 is in autonomous system number 2. So let us consider we have a loopback on R1 and on R2. So we have a loopback 2.2.2.2/it. Now we'll see how to form the adjacency with the help of loopbacks with EBGP. Clear? So let's proceed to the lab. So we have the same topology. We don't have this. Okay, let it be there. So we're forming with the help of loopback 0. This is loopback 0. This is loopback. So form the adjacency with the help of loopback 0, and then we'll advertise the network loop with the help of loopback 1. So R1 is in autonomous system number 1. And R2 is in autonomous system number 2. So wait for the console. So Z0/0 is configured with 12.1, and I have loopback 0 and loopback 1. Now on R2, I have 192.168.12.2, loopback 0 is 2.2.2.2, and loopback 1 is 22.22.22.22. So So let me have the interface first. So interface is 0 bar 0. Auto also. So now, how to form the BGP adjacency? So router BGP 1. BGP router ID will be 1.1.1.2. So neighbor 2.2.2.2. I'm forming with the help of loopback. What is the remote AS? Remote AS will be 2. You need to update the source using the command update source loopback 0. Why I'm updating the source? Forming the adjacency with the help of loopback. Done. So now go to R2. So router BGP 2. BGP router ID 2.2.2.2. So neighbor 1.1.1.1. What is the remote AS? Remote AS will be 1. Update the source. Go back 0. Huh? Check the BGP adjacency. Show IP. Why my adjacency is idle. Reachability. Check the reachability for 1.1.1.1. I'm unable to reach this. So just create a static route. So IP route 1.1.1.1/32. What is the next hop? 192.168.12.1. So go to R1 and create a static route. Using the command IP route 2.2.2.2/32. What is the next hop? Next hop is 12.2. Now they should form the adjacency. Show IP BGP. Still there is no adjacency. Ping. I have a reachability. I'm able to ping. Just check the connectivity for physical interface. Go to ping. Show IP route static. Sure. This was the pre-configurations for yesterday. Sure. Section. Check the reachability. Reachability is fine. But if you check the BGP adjacency, still I don't have any BGP adjacency. Why? Any idea? So the problem with eBGP is, if we talk about the TTL value of eBGP is by default 1 for eBGP, and for iBGP the TTL value is 250. Since the TTL value is 1 here, so with whom I'm forming the adjacency? Not with the exit interface, with the loopback. Correct? I need a TTL of 2. So you need to use the eBGP multi-hop command. So you need to go to neighbor 2.2.2.2 on R1 and execute eBGP multi-hop. You need to increase the TTL value by using this command. That is 2. You need to go to R2. So neighbor 1.1.1.1 and eBGP multi-hop 2. This is the command. TTL, time to leave. So it is the number of layer 3 device that a packet can cross. Clear? Now, so we need to go under BGP and execute this command. So router BGP 1, so neighbor 2.2.2.2 BGP multi-hop 2. Enter. So go to R2. So router BGP 2. So neighbor 1.1.1.1 BGP multi-hop. Now we have found the adjacency. There is a problem of the TTL value. Show IP BGP. Summary. See, now we have a adjacency. I hope the problem is clear. Since we are forming the adjacency with the help of loopbacks, we need a TTL value of 2. So by default, eBGP TTL is 1. Clear? Now, so go and advertise the loopbacks. So let me go to R2, advertise network 22.22.22.22 mask / enter. Go to R1, advertise the network / check show IP BGP. Can you see? Now I can see the. What is the next stop? Next stop is the loopback. First, you need to have reachability, then eBGP multi-hop. Don't forget when you are forming adjacency with the help of eBGP, because by default TTL value is 1. I hope this is clear. Anybody has any doubts? Yes, online guys, any doubts?
In production, generally we make this kind of adjacency through loopback or
Yes.
direct interface.
Adjacency with the help of loopback, because loopback will never go down, right?
Okay.
Virtual interface.
Okay.
Yeah. Clear, guys? Now. So now the concept is, so let us consider we have 6 routers. So we have R1, we have R2, we have R3, we have R4, we have R5, and we have R6. So let us consider all are in the same autonomous system number, ASN 1, 2, 3. Okay. Now, how many iBGP adjacencies we require? Full mesh? How many full mesh iBGP adjacencies? Every router should have 5. What is the total? So we calculate by using the formula n into n minus 1 by 2. So 6 into 5 by 2. So there will be total 15 iBGP adjacencies. So if you consider 10 routers, then how many adjacencies? iBGP adjacencies? Then we have 45 iBGP adjacencies. So you need to create full mesh. So as the router goes on increasing, your iBGP adjacencies will goes on increasing. This is the disadvantage of using full mesh. So in order to break this full mesh, we implement the concept of route reflector. And configuration. So every router should have adjacency with every other router. So R1 will have adjacency with R6, R4, and R3. What about R2? R2 will have adjacency with R4, R3, and R6. What about R6? R6 will be have adjacency with R3 and R5. Correct? What about R4? R4 has R1. R4 will have adjacency with R5. What about R3? Does R3 have 5? So this is the full mesh. So this is the problem with the IBGP full mesh. So in order to break this full mesh, use the concept of route reflector and computation.
So there will be many routing updates and
Yes.
okay, and bandwidth will be
And with the help of route reflector,
okay.
I'll talk about this route reflector, how we implement it. Clear? Now how this route reflector works. So one router will be the route reflector server. We have R2, we have R3, we have R4, and we have R5. So these are the route reflector clients. So in the route reflector concept, so we will be having the adjacency only with the route reflector server. So let us consider R2 wants to update something inside the network. Let us consider we created a new loop. Now this R2 will send the update only to the route reflector server. Then the route reflector server will send these updates to the other routers. But even slave will update, right? If we talk about master and slave, first master will update and then slave will update. But here, only your route reflector server will update to all other routers, not the slaves. Slaves will not have any adjacency with each other. Clear? Now, so with route reflector, we can have three types of peerings. One is EBGP, second client IBGP, and third is non-client. So don't worry, I'll talk about the non-client. What do you mean the non-client? No? So now, so before moving on to the configuration part, so you need to understand 3 rules of route reflector. So rule number 1. So whenever any update from eBGP is sent towards the route reflector, so route reflector will reflect this update to the client and they will update it to the non-clients as well. Don't worry about non-clients. I will talk about non-clients. Just note down these 3 rules. So now what is the second rule? Second rule is so whenever a client updates to the route reflector, so route reflector will send the updates to the client and to the non-client as well. No? So now what is rule number 3? So whenever a non-client updates, so whenever a non-client sends an update to the route reflector, now only client will get that update, but not the non-client. There is no update here. So update will not be reflected to the non-client. This is the third rule. So you need to understand these 3 rules before moving on to the lab.
What do you mean by non-client?
Yes, I'm coming now. No? Now, so what do you mean by non-closed? So again, consider the same topology. So we have R2, R3, and we have R4. So all are in the autonomous system number 120. So one router will be my route reflector server, and one will be my route reflector client. Let us consider this also as route reflector client, and this is my non-client. Now, what do you mean by this non-client is, so for the route reflector client, you need to go to the route reflector server and tell who are your clients. You need to go under router BGP, ASN. Let us consider this as 12.0/24. This is .1, this is .2, this is 13.0/24, this is .1, this is .3. This is 14.0/24. .1 and .2. So now you need to go under router BGP neighbor IP 192.168.12.2, and you need to tell he is my client. So you'll be configuring this as the client, route reflector client. Clear? Even for the neighbor 192.168.13.3, and he is also my route reflector client. So now what do you mean by non-client is, you'll be having a normal IBGP adjacency. That is 192.168.14.4, and you will specify the remote AS. Remote AS is again 123. I will not be telling he is my client. So normal IBGP adjacency. I hope now it is clear. What do you mean by non-client? Yes. Depends on your topology. Let us consider I want to segregate one of the router to not to be my client. Whenever he updates, I don't want to send any updates to the another non-client. So you can use this scenario. Just a scenario we build, not to understand all the rules. Clear?
And how we can see that through command, which
I'm
is
coming to the lab. Coming to the configurations. I'll show you everything. This is understood, right? Okay. Now, so we'll be designing a lab. We'll be having R1. So we have R2. We have R3. We have R4. And we have R5. And we have R6. So R1 to R5 all are in the same ASN, that is ASN 120. And R6 is in ASN 6. Huh? So R1 will be my route reflector server. R2 will be my route reflector client. R3 is my route reflector client. And R4 is my non-client. And R5 is also my non-client. So now we'll prove all those three rules. What you have written. Clear? This is our topology we'll be designing. And inside IBGP, I will be using EIGRP. For the reachability, EIGRP ASN 123. For reachability, inside IBGP. Clear? Let's proceed to the lab. This is clear, right? Everybody is noting it down? Done. Set to the lab. So it takes 6 routers. So we have R1, R2, R3, R4, R5, and R6. So these are in ASN 1, 2, 3. So R6 is an autonomous system number 6. Key BGP adjacency. So now, so the IP address between R1 and R2 will be 192.168.12.0/24. So between R1 and R3 will be 13.0. Between R1 and R4 it will be 14.0. And between R1 and R5 it will be 15.0. Between R1 and R6 16.0. Done. So R1 is my route reflector server. So R2 is my route reflector client. R3 is also my route reflector client. So R4 is my non-client. Non-client means normal IBGP adjacency. R5 is also non-client. And with R6 we have eBGP adjacency. So let us use Notepad for basic configurations. So on R1, hostname, interface G0/0. So IP address will be 192.168.12.1/. No shut. Interface G0/1. IP address will be 192.168.13. No shut. Interface G0/2. So IP address will be 192.168.14.1/. Interface G0/3. IP address will be 192.168.15.1/24. No shut. And interface G0/4. IP address will be 192.168.16.1/20. Okay. So inside IBGP, for reachability, we'll be using EIGRP ASN 120. So router EIGRP 120. So where I need to enable this EIGRP, which all networks? Which all networks I need to enable? All directly connected. Only inside IBGP. I need to run on 12.0 network, 13.0, 14.0, and 15.0. So network 192.168.12.0, network 192.168.13.0, network 192.168.14.0, and network 192.168.15.0. No auto switch. This is by default disabled after iOS version 15.1. So this is on R1. So on R2, hosting. So interface this is 0. So IP address will be 192.168.12.2/20. Okay. Router EIGRP 120. So network 192.168.12.0. No auto sum. So this is the configuration of R2. So router ID, it will by default elect the router ID. So if you want, you can mention the router ID as well. Yeah, otherwise, what is the router ID election criteria? First is manually configured. If it is not manually configured, highest interface loopback. If loopback is also not configured, then it will take the highest interface IP address. Clear? So on R3, so interface G0/0, IP address will be 192.168.13.3. You need to enable EIGRP on 13.0. So on R4, so interface G0/0. Yeah, sure. Yeah, sure, bro. I'll share that. So on R4, so interface G0/0, IP address will be 192.168.14.4 and enable EIGRP on 14.0. On R5, so interface G0/0, IP address will be 15.5 and advertise this 15.0. So now on R6. So interface G0/0, IP address will be 16.6. We don't require EIGRP. Let's copy paste and then we'll enable BGP. Go to R1. Copy paste. Yeah. Go to R2. Go to R3. Go to R4. R5. And R6. So wait for the adjacency. So R1 should see 5 EHRP adjacencies. 4 stripe EHRP. For adjacency with R2, R3, R4, and R5. Clear? So now we'll enable BGP. So I need to go to R1. Router BGP. 1, 2, 3 BGP router. Not 1.1.1. So neighbor 192.168.12.2. Remote AS, that is 1, 2, 3. Enter. Now he is my client. So you need to specify the command route reflector client. This is the only change you need to make on the route reflector server. With the clients, normal IPGP adjacency. So on the server, you need to say who are my route reflector clients. So neighbor 192.168.13.3. So remote AS will be 120. And he is also my client. So route reflector client. Clear? And neighbor 192.168.14.4 and normal adjacency. That is remote AS 120. Is not my client. So I will be establishing only normal IPGP adjacency. And with 15.5 as well. We have one more neighbor, that is eBGP 192.168.16.6. What is the remote AS? Remote AS will be 6. eBGP adjacency. Clear? This is the configuration on R1. Show run web section BGP. So neighbor 12.2, and you need to configure this client. You tell he is the client, and even for 13.3, and for rest of the routers, we have normal IPGP adjacency.
And sir, for making this as a server, we don't need to give any other command.
No, this is the only command. Yes. Only
And
you need to make changes on the route reflector server, not on the client.
And sir, in case we make these kind of command from any other router, let's say R4, so R4 will also become a R reflector server.
No, I didn't get you. What do you mean?
I mean to say similar command if we give in another
yes.
router,
Will also become for the
Then-
backup.
then two server could be exist.
Yes, for the backup purpose. Clear? So on R2, just a normal BGP adjacency. So router BGP 2. Sorry. Router BGP 123. BGP router ID will be 2.2.2.2. Neighbor, I'll have adjacency only with my route reflector server. That is 12.1. Remote ACE will be 120. Enter. This is the only command. So now go to R3. So router BGP 123. BGP router ID 0.0.3.3. Neighbor 192.168.13.1. What is my remote ACE? Remote ACE is 120. Go to R5. Router 23 BGP router ID will be 5.5.5. Neighbor 192.168.15.1 and remote ACE will be 120. To R4. So router BGP 120. BGP router ID will be 4.4.4. Neighbor 192.168.14.1. What's the remote ACE? Remote ACE will be 120. Done. Now go to R6. They establish a eBGP adjacency. Router BGP 6, BGP router ID. Neighbor 192.168.16.1. What is the remote ACE? Remote ACE will be 120. So now we'll check the BGP adjacency on R1. How many BGP adjacencies? So 5 BGP adjacencies. Summary. So have 5 adjacencies. One with 12.2, that is R2, 13.3, R3, 14.4, R4, 15.5, R5, and 16.6, that is with R6. This is clear now. So now what is the first rule? So whenever an eBGP neighbor updates, so it will be sent to the clients as well as to the non-clients as well. Now go to R6 and create a loopback. IP address 6.6.6.6/30. Go under BGP and advertise this network. So router BGP 6 net 6.6.6.6 mask /32. Enter. What is the first rule? Whenever eBGP updates to the route reflector server. So this update will be sent to route reflector clients and to the non-clients as well. So everybody will get an update about 6.6.6.6. Now let's go to R2 and check the BGP table. Show IP BGP. BGP is low. Let's R1 update first. Go and check on R1. Show IP BGP. It's fine. So now go to R2. Yes. Go to R3. R3 will also get the update. Show IP BGP. My problem is show IP BGP. Has got the update. Go to R4 and R5. Show IP. Has got the update. And even R5 as well. My question is why it is not selecting as the best path. This is another just Just worry about this. I hope I am able to see this loop back. So it is not selecting as the best path. I'll talk about this. Why it is not selecting as the best path. This is clear. Whenever eBGP updates to the router reflector server, it will update to the clients and as well as to the non-clients. So now go to a client. What is the second rule? So whenever client updates, that update will be sent to eBGP and as well as to the non-clients as well. Clear? Just make a note as well. Client sends, it will be updated to both eBGP and the non-clients as well. So let's create a loop back here. So IP address 2.2.2./32. Router BGP 120. So network 2.2.2.2 mask slash. Now. So what is the second rule? So whenever client updates to the router reflector server, this update is sent to other clients as well as to the non-clients and as well as to the eBGP neighbor as well. Clear? We'll go and check. Go to R3. Check show IP BGP. Able to see 2.2.2.2. Even the non-clients as well. Able to see 2.2.2.2. And R5 will be able to see. And even R6 as well. Clear? Now, what is the third rule? So go to the R4. So create a loopback. So interface loopbacks. So IP address will be 4.4.4.4/ router BGP 123. Router as a network 4.4.4.4 mask /30. Now, so whenever a non-client updates, so this update is sent to the clients as well as to eBGP neighbor, but not to the another non-client. So now this update on R4 will be seen on R2, R3, and R6. So now go to R2. So R2 will see this update. Show BGP. Able to see 4.4.4.4. So even R3 will be able to see this update. Now, if you go and check on R5, R5 should not see this update. Can you see? There is no 4.4.4.4. But if you go and check on R6, R6 will be able to see this update. These are the three rules you need to understand in Route Reflector. I hope this part is clear. Anybody has any doubts? Clear? So now take a short break. We'll come back. We'll come back at 9:25. Okay, guys. So now, so one more problem with BGP. So what is that problem? Now if you go to R2 and check the BGP table, show IP. Now the problem here is the next term. What is the next term? 16 dot. But who should be my next stop? My next stop should be. So one problem with BGP is whenever any eBGP neighbor updates to